All right, today we are going to work on one-step inequalities. So this year we have worked on one-step equalities, one-step equations, and we've worked on inequalities. Today we're going to go over the basics on how to merge the two. So the first problem, we're just going to plug and chug. So it asks, is this a solution? Is 9 a solution here? 536 is less than or equal to 4 nines, 4 times 9. Is 36 less than or equal to 36? Yeah, they're equal, so that is a solution. I could plug in 12 now. Is 36 less than or equal to 4 times 12? Well, clearly it's not. That gives you 48. Well, it is, I'm sorry, clearly it is. 36 is less than that. If we plug in 6, is 36 less than or equal to 4 sixes, which is 24? No, that's not a solution. Remember, inequalities are a range. Is 36 less than or equal to 4 11s, which is 44? Yeah, that works too. All right, so that was just plugging in numbers. We're going to go over how to really solve these. It's going to be very similar to what we did for one-step equation. So these are the rules for that. I want you to write these rules down. First thing we're going to do is try to isolate the variable. We're going to get the variable all by itself. How are we going to do this? We're going to use inverse operations. So the inverse of addition is subtraction, the inverse of multiplication is division. All right, so here's our problem. Y minus 5 is greater than or equal to 11. So with an equality, remember we drew a balance and both sides balanced. This actually doesn't balance. If this was on a balance, y minus 5, if we think of it like a teeter-totter with the fulcrum here, that's going to be greater than 11. It's going to be unbalanced, but right now we're going to treat it as an equality. Okay, so now I want to isolate my variable. My variable would be y, so I need to get y by itself. To get y by itself, I have to get rid of minus 5, so I'm going to do the inverse operation, which is plus 5. So y over on this side, 16 on this side. Because it's still going to be unbalanced like this, we keep the sign the same. And there is one caveat to this, one exception, which we won't really talk about in 6th grade. I'll talk about at the end of this, just so you're aware of it. Okay, so y is greater than or equal to 16. We could plug any number in for y at the beginning here that is greater than or equal to 16, and it'll work. If I plug in 20, 20 minus 5 is 15. 15 is obviously greater than or equal to 11. Okay, problem 2, or problem 3. 17 is less than or equal to v plus 5. We're going to isolate the variable. So I want to get the v all by itself. To do that, I have to do the inverse of plus 5, so minus 5 to both sides. 12 is less than or equal to v. All right, question 4. 21 is greater than z minus 10. Draw your balance. We want to get the z alone. To do that, we get rid of minus 10, so we add 10 to both sides. 31 is greater than z. Okay, question 5. 48 is greater than 8y. Okay, so we want to get y by itself. So we have 8 times y, so the opposite of times 8. We want to divide both sides by 8. So 6 is greater than y. Okay, question 6. I changed a little bit to make it a little harder. 7y is less than or equal to 54. I want to isolate the y. So to do that, I divide both sides by 7. Now we're going to end up with a fraction or a decimal. So 7 goes into 54 7 times with a remainder of 5. I'm going to leave it as a decimal or as a fraction then. 7 with a remainder of 5 out of 7. 7 and 5 sevenths. Y is less than or equal to 7 and 5 sevenths. right, question 7, I made it a little tougher too. I want you to change it to this. U divided by 6, U over 6 means U divided by 6. So when you rewrite it, you could rewrite it either way. It's greater than or equal to 5. We want to isolate the U, so we do the opposite of divided by 6, so that's times 6. U is greater than or equal to 30. Okay, so now the one caveat, the one exception. When you multiply or divide by a negative, you flip the symbol. You flip the inequality. Okay, so I don't expect you to know this. I just want you to see it here. If we would have said like -6, and you don't have to even write this. If I had -6 here and I multiplied by -6, then this symbol here, instead of being greater than or equal to, would be less than or equal to. Again, I just want you to be cognizant of that in case you get to those higher ones in ALEKS, but you'll see that next year more than this year. All right, now on to the two toughest problems, two of the tougher ones in ALEKS. I'm going to show you the way we just did it, but I'm also going to show you how to do it a little bit easier. Charmaine will run at less than 29 miles this week. So far, she has run 15 miles. What are the possible number of additional miles she will run? Use T for the number of additional miles she will run. Okay, so far she's run 15. And she's going to run T more miles, so 15 plus T. And we know she's going to run less than 29. So knowing that, we have to figure out what symbol we're going to put in there. So 15 plus T is actually going to be less than 29. All right. Could it be exactly equal? No. So it's got to be a less than symbol. Okay, so I start with this. 15 plus T is less than 29. Again, we want to isolate our variable. To do this, I subtract 15 from both sides. T is less than 14. And like we did yesterday, I should try with a smaller number, the number itself, and a bigger number, and see if that works. If they run 0 more miles, does that make sense? Yeah. If they run 14 more miles, does that make sense? No, that'd be exactly 29. If she runs Charmaine is a girl. If she runs 100 miles, will that make sense? No. 0 is the only number that should work in there. Okay? Now the other way we can do it, I'll do it the other way on this next one. Instead of setting up a one-step inequality first, I'm going to do this math first and then have an equation, inequality. LaShonda will spend more than $25 on gifts. So far, she has spent $12. Okay, so I'm going to go ahead and do this math right now. I know I'm going to use the number 13. 25 minus 12 is 13. So 13 is going to be my ending number. Just like above, I ended with 14. I got to look back at here and then 29 minus 15 is 14. Okay, so I'm just doing that in my head right off the bat. Okay, so what are the possible additional amounts she will spend? Use C for the additional amount LaShonda will spend. Okay, so C and 13 is what I'm going to use. So now I just need to figure out what inequality I want to do. Okay, let's guess and check. So let's see, 13, let's try $1, and let's try $100. Is she allowed to spend just $1? She's going to spend more than 25? No, that doesn't make sense. Could she spend exactly 13? No, because she's going to spend more than 25. Could she spend 100? Yeah. So whatever inequality symbol I plug in here, it's got to be something that C can be 100, but it cannot be 13 or 1. So C has got to be greater than 13. Okay? Can't be equal to, can't be exactly 13. All right, that's how we do one-step inequalities.